Okay, guys, so this is the part in your packet where you have definitions for the 5 forces we talked about. Now up here, y'all, force applied, remember that's the applied push or pull, always in the direction of motion. Friction and air resistance, if they are there, air resistance is always on things that are moving, are always hindering you. It's always in the opposite. Friction doesn't help you go forward. It actually slows you down. So it's opposite. Same with air resistance. Gravity is always downward and normal is always upward, or basically perpendicular to the ground. Okay? So here are all more explanative definitions, but I mean, we went over it in our notes. Okay, so you will get one of these on your quiz tomorrow, but it's just teaching you. If vectors are opposite each other, you subtract. And this is a good example down here that we do. It'd be like 2 dogs pulling on a bone to either side. Okay, you subtract, and the resultant vector that's the greatest, that's the direction that the bone or the dogs are going to be going on. Okay, if the 2 vectors are going on the same side, then you add them. So that would be an example of, okay, we got Braden in the middle. If Eddie and Cody were both pulling on Braden, okay, Braden would be going in the direction of the greatest push or pull. But if Eddie and Cody were on the same side pulling Braden, you would add their forces together and he would basically go in that one direction. So we're just going to practice saying, okay, if they're opposite, you subtract them. If they're on the same side, you add them. Okay. So the net force or the unbalanced forces is the vector sum, all of them, addition of all the forces which act upon an object. To say this, the net force is the sum of all forces taken into account the fact that a force is a vector and 2 forces of equal magnitude in opposite direction will cancel each other out. Okay, we'll keep that in mind. Here is our example. And we will take 1 or 2 notes to the side, so I'll leave a little bit room for notes. Okay, so don't love this free body diagram. Remember, we always need to have that center core. Okay, got it. I like that better. Now, they have a 1,200 Newton force upward and an 800 Newton force downward. First off, they made their arrows different. I like that. Which arrow did they make larger? The top one, because the top one has a greater number or magnitude. Okay, I'm not going to take off points when we do this for our free body diagrams, but that's a good illustration how the greater the magnitude, 1,200 over 800, the greater the arrow. Okay, so they just told us if they were equal, they would cancel out. So if Cody was pulling with 800 and Eddie was pulling with 800, would Braden go anywhere? No. But what's happening is one is pulling with 800, the other's pulling with 1,200. So this is all it is a subtraction problem. So here's your first note. Y'all could take the note underneath here or to the side. So here's our first note. Okay. When vectors, V-E-C-T-O-R-S, when vectors are in opposite directions, so when vectors are in opposite directions, you subtract to find the resultant, basically the resultant vector. Okay, the resultant vector. We got 2 more notes, so when vectors are in opposite directions, you subtract to find the resultant vector. And then the next note for the subtraction is the direction of the resultant vector is in the direction of the greatest original vector force. So, since the greatest original vector force was the 1200, when we do our subtraction, the 400, 1200 minus 800, the 400 newtons is then in the direction of that original greatest vector, the 1200. So, top one. When vectors are in opposite directions, you subtract to find the resultant vector. The direction of the resultant vector is in the direction of the greatest original vector. So once again, we subtract because it's opposite. Okay, so the resultant force vector, okay, is 400 newtons. And because 1200 was greater than 800, then the resultant direction would be up. Okay? Our last little note, you can put it on the side, is you add vectors that are in the same direction. So it's just add vectors in same direction. And so say if we had that box again, but instead it was a force 800 newtons downward, and then another force 1200 newtons downward. So if they're both in the downward direction, our resultant force vector, what's 800 plus 1200? 2000 newtons downward. Okay? So, easy peasy. When they're opposite, you subtract, and whatever that result is, it's in the direction of the greatest original one. If they're in the same direction, you add them. Okay, so let's do our example right here with the dog. So let me read it while people are finishing, and then we'll draw it out. Two dogs are fighting over a bone. One is pulling to the left with a force of 20 newtons. Another is to the right with a force of 35 newtons. Draw a free body diagram and calculate the net force on the bone. Okay, so remember, you do not have to be an artist. You can draw a box that says bone in it, or you could just try, y'all. Now remember, our free body diagram is our picture pulled out from what's going on. Do we have to draw the dogs? No, we're only concentrating on one thing. If it helps you to draw the dogs, okay, but you only have to draw that one item. Okay, put my center circle. Two dogs are fighting over a bone. One is pulling to the left, right, left, okay, with a force of 20 newtons. Okay, y'all, what do I call this force? Is it force applied? Good. So this dog one has a force applied of 20 newtons, and as you can see, it's to the left. Okay, and another to the right. So then this one is a force applied of 35 newtons to the right. Awesome. So there is 2 points right there for your free body diagram. That's what y'all get tomorrow on your quiz. Now, it did ask you, then calculate the net force. The net is either doing that subtraction or the addition. What are we doing here? Addition or subtraction? Subtraction. Good. So, everybody can get a calculator too if you need it. Okay, but our resultant vector, or just the resultant force, equals, okay, 35 minus 20 is what? 15. Don't forget our newtons. What direction are we doing it? Good. It's in the direction of the greater original vector. Okay, can you do that tomorrow? Absolutely. Okay? So you will only get one. Out of the 10 questions you're given, you're only going to get one like that. It's either going to be pulling to the same side, you add them, pulling to the opposite side, you subtract them. Okay, y'all go into the lab. Let's go over the rest of this. We have nothing to do after this because this is your quiz review.
Wait, he said I'm gonna come back and check my answers.
Yeah. Okay, so let's go over this. Okay, over here on this board, just because I'm always going to refer to it, I'm going to put all the forces. So I have force applied, force friction, force air resistance, force gravity, force normal. Okay. Remember, it could be one of four scenarios. Those four scenarios that are on that image, you're either going to be moving on the ground, moving in the air, free falling, or stopped. Okay. A book is at rest on a table. You don't need to draw the table, but maybe it'll help you. Okay, so here's my table, and the book is just at rest. Okay, if it's at rest, does it have a force applied? No. If it doesn't have a push or pull and it's not moving, should it have friction or air resistance? No. Okay, so everything that has gravity, and if something is on a table, on a floor, on something that's on the ground, it pushes back up on them, and that is your normal force. This one would be worth 2 points on a quiz. Okay, and a book falling off a table. Okay, so that's like the book. Okay. Now, are they giving you any indication that the book is being thrown, pushed, pulled? No. So we have to assume that it's just free falling. Okay. It is moving, but we're not going to say force applied. Friction. Is it touching anything solid? No. It's got air resistance. Is the air resistance down or up? This is the direction of motion. Good. Air resistance is opposite motion. Force, air resistance. Everything has the force of gravity. It doesn't have normal because it's not on surface. 2-point question. Guess what? Number 3 is exactly the same. An egg free falling from a nest. Free falling. It just means it rolled out. Same as before. Everything has a force of gravity. There's no normal because it's not touching anything. There's no friction. It didn't say there was a push or pull, no applied, but there is air resistance in the opposite direction. Another 2-pointer. Okay. Okay, so I did not specify direction here, but I will on your quiz. So flying squirrel is jumping from one tree limb to another. Okay, so I do not need to be drawing trees, but it's just gonna reiterate. Okay, midair. Okay, so I'm going to draw, I'm gonna try to draw a squirrel. Nose. He's trying to reach really hard. That's not terrible. It's more like a cat. That's fine.
My squirrel better than yours.
Mm-hmm. Do you want to come and fix it now?
No.
Okay.
I ain't drawing squirrel. I just do five.
That says squirrel. That's probably a smart thing. Okay, y'all. So now the squirrel uses its little legs to push off of one tree branch to another one. So it is using a force applied. Okay. I am doing my force applied in this direction, but if I would say the squirrel is jumping northeast, make sure it's in that exact direction, okay? Now, friction and air resistance. No friction because there's nothing on its feet right now, but air resistance is always in the exact opposite motion. Okay, no normal because it's not on the ground, and then everything has the force of gravity. This would be a 3-pointer. Okay. A rightward force is applied to a book in order to move it across the desk. So guys, this is an example of moving to the right, the car. So this is our example of the car or the baseball player running. This should have all 5. My rightward force, so ready? The force applied is rightward. It is across the desk, across this friction surface. So it has force of friction. Everything moving has force of air resistance. Gravity always pushes down, and because it's on a surface, normal is pushing up so it doesn't just melt down in the ground. This would be a 5-pointer. A book falling off a table midair. So y'all, that's the same as the egg, same as the book from before. If the book is just falling, it's just the force of gravity and the force of air resistance. Do y'all see how these are so repetitive? There's only 4 I could ask you. Every single one falls into all 4. Good. Next page. A skydiver is descending. Same as the book falling, y'all. The skydiver. I'm not going to draw that. I'll just write in the box skydiver. That's what I heard. Okay. Okay, it did not say the skydiver was pushed or pulled, so we're just going to assume free falling. That is, again, just the force of gravity. Yeah.
You got some beeping over here. Some about to blow up.
It's that watch again.
Something for the blow up, Miss Spice. We gon'
Boom. No, I gotta watch
Last night I was watching the Strikers.
Uh-huh.
That's wild.
You talking about the Hellcats?
Hellcats?
Yeah, I know.
Well, where they like shoot out, break the
Oh,
bank.
yeah, we can't say that.
Okay, almost done, almost done. We got 3 more. Okay. Okay, this is going to be the hardest one. You will have one like this on the quiz where I'm not trying to trick you, but you really got to think about it. So, a child is sledding downhill. Draw a free body diagram, one for the sled and another for the child. Okay, first of all, southeast. So remember, never eat soggy waffles. Okay, southeast. Okay, southeast. So this is the hill. Now, you don't have to draw the kid and the sled directly together because I need to see which is which. Okay, so I'm drawing my sled right here. And then I am putting my kid right here. And I will do the free body diagram. They will not be the same. Okay, the sled. I did not say it was an ice hill, so I am assuming friction. So I'm going to put everything on this, just like that moving car. So we have force applied. We have forces of friction and force of air resistance. We have gravity. And we have, I'm going to just do a little normal force so the things don't mesh together. Okay, person is a little bit trickier. Okay, everything has gravity, so let's just put gravity on it. We know that's easiest. Also, something pushed or pulled that kid forward, so they do have a force applied. Something is moving it. Okay, everything that's moving has air resistance. Does this kid have friction? Is anything moving across that kid's behind? Is he moving through? Nope. So this kid does not have friction, but they are moving, and he is on an object, but the other object is moving. He is not moving on the sled, but the sled is moving. Y'all get that? Okay. Is there normal? Yes. So remember, his butt is on the ground, and his butt is on the sled is on the ground, he's not meshing into the ground, so the normal force is pushing up. This would be a 9-point question. Almost done. Last 2 are easy. A football is moving upward towards its peak after having been kicked by a puncher. I would assume upward would be directly up, but I'll specify it for your test. So if I was going to just do an upward, like upward, and it's okay if you did a sideways upward, it's the same thing. So my force applied would be upward, or if you drew it to the side, that's fine. Your air resistance has to be directly opposite. There's no friction, there's no normal, and the gravity is also this way. If you interpreted it to where the kick would be this way, it would be force applied, force, air resistance, force, gravity. Okay. Last one, football setting on a tee. An object not moving. Force normal. Force gravity. Okay, was that the last one? Any questions? If you have any questions, y'all got your quiz tomorrow.